going to look at larger systems now, systems with 3 equations. And in this case, I'm going to do Cramer's rule in the most general form and then give you an example. It is very similar to the 2 equation case, except now I've got more letters involved. But again, we're going to define the variables in a very similar way, so that the variable d is simply the determinant of the 3 by 3 matrix of coefficients. So it'll be A, B, C, D, E, F, G, H, I. Okay, so that's your D matrix. Then you have the D sub X matrix. Better slide this up. The D sub X matrix is the D matrix, except the X column is removed and replaced with the constants. So you'll have STU going down, and then the other 2 columns are the same. So B, E, and H, and then C, F, and I. Okay. We need a determinant for each variable, so we need a d sub y, and then we'll also need a d sub z in this case. So the d sub y, I replace the middle column with the constant. So we're going to be going down. It's going to be ADG, and then the constants STU, and then the coefficients CFI. And then finally, d sub z is going to be just like the original matrix, except with the z column replaced with the constants. So we get ADG going down, BEH, and then ST and U. Right? And so those are our 4 matrices, and then the XYZ values are going to be represented by the ratios, similar ratios of these matrices. You start with the d sub x and divide it by d. The y value is going to be d sub y divided by d, and the z value is going to be d sub z divided by d. Okay, so again, very similar to what we saw in the 2 equation case. This time I'm going to go through and apply this technique, this Cramer's rule, to a specific example, and again, this is one that we've seen before from a previous video, the one that had these weird fractions with the 13ths on the bottom. I'm going to go ahead and do that one, and you'll see how the determinants show up. Okay, so let's look at this system. It's 2x plus y minus 3z equals 0. Try to write this out quickly. 3x minus 4y minus 3z equals 7. Okay, so we're just going to look at those 4 determinants, and they take a little bit of time to calculate. It's true. So the determinant D, again, is just your 3 columns of coefficients. I'm just going to go ahead and write them all out. So 2, -2, and 3. 1, 2, -4, -3, 1, -3. And remember, when I calculate determinants for a 3 by 3 matrix, I repeat the first row, the first column and the second column. Okay. Then we do our diagonals, our multiplication on the diagonals. 2 times 2 times 3 is 12, and it's negative. 1 times 1 times 3 is 3. 3 times 2 is 6 times 4 is 24. 3 negatives make a negative. Going up, 3 times 2 times 3 is 18. And 1 negative. 4 times 1 times 2 is 8. Again, 1 negative. 3 times 2 times 1 is 6. It has 2 negatives. But then I need to go through and change all the signs on top. So plus, plus, minus. Then when I tally these up, I get negative 12 plus 3. Well, you know what? Maybe it's just easier to tally them up top and bottom and add them. Let's do it that way. Negative 12 plus 3 is negative 9. Negative 9, negative 24 is negative, just lost it, 33. Yeah. On top, 18 and 8 is 26, minus 6 is 20. And so we take the bottom, which is negative 33, add the top, which is 20, and you get a negative 13 as the D value. Okay. Now, of course, I've got to do this 3 more times, so this is not a super short process. We go D sub x next. So we replace the x column with the 3 constants. So we'd have 0, negative 7, 7, and then everything else is the same. 1, 2, negative 4, negative 3, 1, negative 3. And then again, repeat the first 2 columns. It's very important on these, I would say, to be careful to line everything up correctly and really be neat and organized. Otherwise, it gets to be very, very confusing. What's this? 21 times 4 is 84. Going up here, 6 times 7 is 42. There's a 0. I like having the zeros in there. They're just a lot easier, right? 21, and it's positive. Then I have to change all my signs on top. That one doesn't matter. And combine them on the bottom. That's a negative 77, and on top that's going to be a negative 63. So then I get, that can't be right. But it is. Interesting. 0, 7. Is that right? 84. Yeah. Just double checking all my arithmetic because something's not turning out the way I expected it to. Well, negative 77 and 63 makes 140. That is definitely not what I was expecting to see. I'm gonna stop this one for a second.